Hey everyone, and welcome. Today, we've got a really fascinating story from the world of AI. It's one of those classic David versus Goliath tales, you know? We're talking about a smaller but incredibly clever AI system that's challenging the absolute giants of the industry. And it's proving that in the race for intelligence, smarter might just be way better than bigger.
So, let's just start with a big question that's really shaping the whole field right now. Does an AI model actually need to be enormous to be intelligent? For a long time, the answer seemed to be a definite yes, but, well, that whole assumption is being seriously put to the test. All right, so to really get why this is such a potential game changer, we have to look at the main philosophy in AI today. It's an approach that's led to what you could pretty much call a size problem. Right, so this is the core idea behind what are called scaling laws. For years, the wisdom in the field has been pretty straightforward. If you want more powerful, more capable AI, you just build a bigger model. More data, more computing power, and, the big one, more parameters. Just scale it up. And this has kicked off a kind of technological arms race. I mean, just look at the scale here. On the left, that's our protagonist, K2 Think, at 32 billion parameters. Now compare that to some of the other big open source models, GPT-OSS at 120 billion, or Qwen 3 at just a whopping 235 billion. The difference is absolutely massive. But these Goliath models, they come with some pretty serious downsides. It costs a fortune to train and run them, they use up incredible amounts of energy, and a lot of the most powerful ones are kept locked up, proprietary and closed off from the rest of the research world. That really creates a bottleneck for innovation.
And that's exactly where our challenger comes into the story. So let's meet K2 Think, the system that's designed to prove there's a different way to do this.
So what exactly is K2 Think? Well, it's a 32 billion parameter reasoning system, and it's built on the open-weight Qwen 2.5 model. But its whole design philosophy is completely different. It's all about what they call parameter efficiency, getting the absolute best performance without needing that crazy, colossal scale. The goal is to compete with the big guys, but in a much leaner, more accessible package. Okay, let's dive into the secret sauce, because this is the really cool part. How on earth did they pull this off? Well, it's not just one magic trick. It's a super carefully crafted recipe, and it's built on 6 key pillars that are spread across 3 different phases. So here's the 10,000-foot view of the process. It kicks off with advanced training, which is all about teaching the model how to reason. Then it uses something the creators called test time smarts to make it think more effectively when you actually ask it a question. And finally, it's all brought together with a supercharged deployment to make it unbelievably fast. Phase 1 is all about the training. First up is supervised fine-tuning, where they show the model tons of examples of long, structured reasoning. Basically, they're teaching it to show its work. Then they use this technique called reinforcement learning with verifiable rewards. This is just brilliant. It directly rewards the model for getting the right answer in areas where you can actually check the answer, like math problems or generating code.
And that foundation leads us into phase 2, which is, it's just so clever. Instead of just throwing a question at the model, they use this plan before you think method. Your question first goes to a planning agent that creates a high-level outline. Then, that plan plus your original question gets sent to K2 Think. And get this, it generates 3 different possible answers. Then, a whole separate AI model comes in to act as a judge and picks the very best one. It's kind of like giving the AI a smart assistant and an editor, all in one.
The last piece of this puzzle is all about speed. They use a software trick called speculative decoding to make the text generate way faster. But the real game changer here is the hardware. K2 Think is deployed on the Cerebras wafer scale engine, which is this massive specialized chip that's optimized specifically for this kind of work. So we've got this really clever recipe, right? A mix of training, planning, and specialized hardware. But does it actually work? Can this little 32 billion parameter model really go toe-to-toe with the Goliaths? Let's take a look at the scorecard. And this is the moment that makes you sit up and really pay attention. Looking at a collection of complex math benchmarks, K2 Think, with its 32 billion parameters, scores a 67.99. Now that's not just good, it actually beats GPT-OSS, which is nearly 4 times its size, and it blows past Qwen 3, which is over 7 times larger. This is the proof right here that clever engineering can absolutely win out over just brute force. But performance isn't just about getting the right answer, it's also about speed. And K2 Think can crank out over 2,000 tokens of text every single second. Now, to put that number into perspective,
That kind of speed makes a staggering difference in the real world. Let's say you ask it to generate a long, complex response, like a detailed mathematical proof of about 32,000 tokens. On a top-of-the-line GPU, that would take around 3 minutes. K2 Think does it in just 16 seconds. That's the difference between waiting around for an answer and having a real, fluid, interactive conversation.
and here's a cool little bonus they discovered. That plan before you think step, it doesn't just make the answers better, it makes them more concise. Because the model has a clear plan, it doesn't just ramble on. The result is that the answers are up to 12% shorter, making it more efficient all around. So, when you step back, this isn't just a story about one clever model. It really represents a potential shift in how we think about developing AI altogether. The creators of K2 Think really nailed their goal with this quote. It's all about empowering small models to punch above their weight, to get them to a level of performance that everyone used to think was only possible for the biggest, most expensive systems out there. And this is exactly why this matters for all of us. This research opens up a whole new path for AI development, one that's focused on efficiency and cleverness instead of just raw size. It makes these powerful reasoning tools more affordable and accessible for smaller companies, for researchers, even for individuals. And by building on and supporting open source systems, it helps to democratize the future of AI. You know, the team behind K2 Think didn't just publish their research and call it a day. They took it a huge step further. This isn't just some code and data you can download. It's a living, breathing system that's publicly deployed for anyone to go and try out right now. You can go and stress test it and see this efficiency in action for yourself. Which leaves us with one last really fascinating question to think about. If a 32 billion parameter model with the right recipe can do all this today, what does the future of AI look like when the entire field starts focusing more on cleverness instead of just raw scale? Now that is an exciting future to imagine.